Hello guys, welcome back to my YouTube channel. I am back with another video on data science lecture series. In this video, we are going to cover logistic and Poisson regression. So let's start with what is logistic regression. It is a supervised machine learning algorithm which is used for classification tasks where the goal is to predict the probability that an instance belongs to a given class or not. If we take an example of a student and take some features like how many hours he studies, so we can classify whether he will pass or not. So logistic regression is used for binary classification where we use sigmoid function that takes input as independent variables and produces a probability value between 0 and 1. So the logistic function which we use is the sigmoid function. The sigmoid function is a mathematical function used to map the predicted values to the probabilities. It maps any real value into another value within a range of 0 and 1. The value of the logistic regression must be between 0 and 1, which cannot go beyond the limit. So it forms the curve like the S form. The S form curve is called the sigmoid function or the logistic function. In logistic regression, we use the concept of the threshold value which defines the probability of either 0 or 1, such as values of the threshold value tends to 1 and value below the threshold value tends to 0. Suppose the example you've taken of a student, in that case, if the threshold value of how many hours he studies is 5 hours. So if he studies less than 5 hours, then he is probably going to fail. So we can classify it into failed class. And if he is studying more than 5 hours, then he will pass and we will classify it in passing class. So now let's move forward. Performing logistic regression. It predicts the binary outcomes. It predicts the probability of a binary outcome, yes or no, based on independent variables. Then the sigmoid function, which transforms linear combination of independent variables into probabilities between 0 and 1. Then comes model evaluation. Common metrics include accuracy, precision, recall, and AUC to assess the model's performance. Now let's have a look at the logistic regression implementation code. First, we are importing pandas, then NumPy, then Matplotlib for plotting, then train test split to split the data set, then importing logistic regression from sklearn.linear model for training the model. Then for evaluation, we are importing confusion matrix and classification report. And first of all, we are creating a simple data set. The example which we have taken was study hours and whether the student passes or fail. Here, zero is equal to fail and 1 is mapped to pass. The study hours are 1, 2, 3, 4 to 10. So we are creating a data frame of the above data set and we are plotting the data and then we are splitting the data set into training and testing sets. Okay, which is done using train text split. Then we are creating a logistic regression model using logistic regression, calling the logistic regression. Okay. Then we are fitting the model to train the data by passing the data xtrain and ytrain into model.fit. And we are making predictions on the test data using model.predict by passing the extract values. Then we are evaluating the model. Now let's have a look at Jupyter Notebook. Okay, so this is the sample snippet where we have imported all the necessary requirements and then we created a simple data set of study hours and pass or fail. Then we have created a data frame, then we plotted the data and we split the data set into testing and training sets. Then we have created a logistic regression model. Then we are fitting the model to train the data, then making predictions on a data set. Now if we try to run this code, you can see that we are getting this output. So if study hours are less than 5, we can see that it is considered as failed, which means it is giving output to be pass of 0. So it is failed. And if study hours are more than 5 or equal to 5, then the student passes. So this was logistic regression. Now let's move forward to Poisson regression. Okay, so performing Poisson regression. First, it predicts count data. Poisson regression models count data where a dependent variable represents the number of events occurring within a given time or space. Then Poisson distribution. Poisson distribution describes the probability of a given number of events occurring in a fixed interval of time or space, and it assumes that the dependent variable follows the Poisson distribution. Model applications. Applications include predicting customer arrivals at a store, accidents on a highway, or disease incidents in a population. If we take an example of doctor also, doctor visiting a patient. Now we are implementing Poisson regression. First, we are importing the NumPy as NP, then Pandas as PD, then Poisson regression for training the model, uh, and then creating a simple data set, how many years lived, and doctors' visits, count of doctors' visits. Okay, so create a data frame. Creating a data frame using pd.data frame and display the data set. And we are preparing the features of X and Y. Uh, Features need to be in 2D array. So we are providing years lived in a 2D array. Then doctor's visit, which is the target variable. So it is gone into Y. Then we are fitting Poisson regression by first of all creating a Poisson model using following Poisson regression. Then we are fitting the model using Poisson model.fit, passing the XY values. When we are predicting, making predictions by Poisson model.predict, then we are displaying the prediction. So let's have a look at sample code snippet in Jupyter Notebook. Okay, so this is the sample code. Here, this is data set. We created a data frame, and then we have prepared the features for X and Y target, then fit Poisson regression, then we are making the predictions. So we try to run this. You can see that this was the original data set. Okay, so years lived 1 and doctors visit 2. Years lived 5 and doctors visit 7. And this is the predicted value. These are the predicted visits. So you can see these values are matching 2, 2.3. These are very close. 3, 3.0, 3.9, which is nearly 4, 5.1, which is 5, 6.67. So these are the predicted visits. So we have covered logistic and Poisson regression. And that's it for now. मिलते हैं अगली वीडियो में. Till then, keep learning, keep exploring, and thank you for watching.